Hello, we're back to show the results that. Uh, so here are the results that we obtained. So first, in general, the trend was as we increase the number of sets in a cache, that is, we tried and increase the cache size, the IPC went up. This was because of less number of misses. Also, graph analytics have a property that the reuse distance is such that it allows for optimal L1 and LLC use. L2 doesn't really come in the picture that much. So our main goal was to try and optimize the LLC as it was the most important factor for graph analytics.
So this is another particular result that we observed. So what this shows is that some policies tend to have a decrease in their IPCs, even though we are increasing the cache size by increasing the number of sets. But that is explained because of the corresponding latency increase we are doing along with the cache size. So for example, here LRU faced a decrease in IPC despite an increase in the number of sets. But for example, the random and FIFO policies continuously benefited from the increase in sets. So that shows a trade-off between size and latency.
Then we also focused on how individual policies affect the different traces. So for the BFS trace particularly, the FIFO policy was the best in regards to that it gave the highest IPC. That can be attributed to the fact that the BFS itself can be analogous to a queue-based algorithm, and the FIFO policy also is a queue-based algorithm with the first in first out principle.
So now we'll just discuss about some of the issues that we faced in the implementation. So firstly, like the ChamSim code was not very clear about their implementation. So that led to a lot of hunting for what exactly some variables meant and why some asserts were there, which we continuously faced. So
But looking through that code was a very great learning experience because not all code that you'll ever see will be very well documented. So we had to hunt a lot of things, but it was a very good learning experience.
Also, one of the things in the Chamsing code was that we were not able to understand some of the definitions of the basic functions itself. If we were trying to code the different hierarchies without completely understanding the definition of the functions, and that led to some infinite loops running in the program, and we were very perplexed like how to solve them. But then by doing a deeper analysis of each and every line, that helped us to solve all these problems, and we are finally able to persist and get the results as seen.
Thank you.
that
Team Cherry
concludes our
Blossom.
presentation.
Thank you so much.
Team Cherry Blossom signing off.